This video is the first part in a series where we are going to learn how to make a compute shader using ModernGL, which will run on your GPU. So in this video, I'm just going to explain some stuff and just teach you the basics. And yeah, in the next videos, we'll try to simulate like particles. We'll try to do some physics simulations and stuff in next videos. So to get started, what we'll do is, you can see I have PyCharm open here. I'm going to first pip install ModernGL, and that's just going to install the ModernGL Python package. What this does is it allows you to write shaders. A shader is just a program for your GPU, and you can use it with your integrated GPU or your, like, if you have a dedicated GPU, you can use it with this. Now that it's installed, we'll go ahead and create two files. We'll create a main.py file, and then we'll inside attributes we'll create a we'll say just shader dot I guess GLSL. Obviously, if it's not, we're just going to read this in main.py, so you can provide any name and any extension you want. Okay, now what we're going to do is first we're going to import ModernGL. And since we're making a compute shader, not like actual graphics, we're going to define context. So context is ModernGL dot create standalone context. So this doesn't require like a window for it to like where display stuff. And then we're not going to pass any arguments, and we're okay. Next, what we're going to do is we're going to have an array, and with that array we're going to just multiply all of those values or square all of those values, whatever you want. So what we're going to do, we're going to define a buffer. So basically it's just an array in GPU terms. We're going to say context.buffer, and then actually over here we need to also import numpy as np, and we have to obviously pip install numpy. First you have to spell it properly. And then we're going to say data, it's going to be np.random dot we'll say uniform, and from 0 to 255, let's say like you're choosing a grayscale color or something like that. And then we'll say the size equals, we'll just say like 100 or something. You can obviously increase it to a lot more since you're doing it on the GPU. And then dot as type, so we're going to just turn it into f4. There's a float 4, which would be 32-bit float. And then in buffer, we're going to say data dot 2 bytes. Just convert it to bytes. And now what we're going to do, we're going to say with open. We're going to open our shader.gl file or shader.glsl file. We're going to say with open. We're going to open our shader.gl. So for me, it's in attributes slash shader.glsl. Okay, GLSL is just OpenGL shading language, and then we're going to open it as file, and then we're going to say the shader source. So the source of the shader will be file dot read. We're going to read the contents of the file, and then over here we're going to say the program or just prog, whatever you want to call it. That'll be context dot compute shader, and then we're going to pass shader source here. And then what we're going to do, we're just going to say prog dot, we're going to run. And then we're just going to multiply all of these numbers, all of these random numbers times 2, or we can square them or whatever, and then we're going to just store it into the same buffer. So then what we're going to do, we're going to say result equals, we'll say buffer, we're actually going to say np dot from buffer, and we'll pass our buffer object here. Buffer, we're going to say buffer dot read actually, and then we're going to say the D type. It is an F4 float 32, just like this, and then we're just going to say print. We're just going to print the first, let's say first 10 indices of result, and now this will run. If we run it, you have to go out, and now it will run. So this will run, but we haven't written the program yet. This nothing here. So here we're going to specify the version. So we'll say version. So a hashtag version. We'll say 430. It's just the version of the language and OpenGL features that we want to use. We're going to say layout. I'll explain this here. We'll say local size x equals 1, and then we're going to say in. So what this means is what the GPU does, it works, or what this does, what ModernGL does, it basically has work groups of threads, and you're just defining a local size x equals 1 basically means for each work group you only have one thread. Now obviously that's way too small. A modern GPU can handle, like my RTX 4060 can handle, like I think 49,000 threads. So obviously one thread per work group is way too small, but just for testing, we're going to do this. And then in basically means at runtime, the input layout is this, the local size X. So we're going to have one thread per every work group. And then we're going to define another layout. We'll say a standard 430. And then we're also going to specify the binding. So we're going to define a buffer here. So the binding will be 0, and then it's going to be a buffer. We can call it whatever we want. I'm just going to select input like this, and then we're going to say just say array. No, we have to define float because this is not Python. So we're going to say float array, and we have to put square brackets to define an array, and obviously you have to put a semicolon after almost each of the lines. And then what we'll do here, we'll say void main. So this is the main entry point. And then what we'll do, we'll say I equals, I'll explain this. We'll say I is GL underscore global invocation ID dot X. So as I said earlier, you can have multiple threads per work group. So we're just getting the thread index or thread number. And then we're going to just say array of I, which is just, we're going to assign one thread for one index. So let's say we want to multiply it by 2. So array of I times 2. That's all you have to do. So I'll explain this. What we're doing, we're saying we want one thread per work group, and that's our layout. And then we're saying we're going to create a buffer called input. And what that's going to do, it's going to bind to 0, and it's going to have an array, a float array. It's called array. And we have to put a semicolon here. And then the main function, which is just like the entry point, we're going to say I equals GL underscore global invocation ID dot X, just which thread is executing right now. Because the thread will execute in parallel. So we need to get to know which thread is executing. And then we're just going to say array I equals array I times 2. So each thread has its own index basically. And then over here we also have to do some more things. We have to say, and then there's actually one more thing. We have to actually bind the buffer. So buffer dot bind, we're going to bind to storage buffer, and we'll say it's 0 because over here what we did is we defined the binding for this buffer is 0. So we're going to bind it here also, just like that. And then in this program dot run, we also have to specify group X. So like how many work groups do we are we running here? So since we have 100 well indices in our array, and one work group only has one thread, so we would need 100 threads, or we need 100 work groups to do all of them in parallel. So now if I were to run this, and then actually here we have to say it's a u and I, and then you can see here we've actually did done it, and it's just essentially doubled each of the values. And since it's a numpy array, there's no commas when it prints. It's a numpy array, not like a normal list. But that's it for this video. In future videos, I'll be explaining how to use it more generally and better, where you can actually compute things that you need, not just multiply an array times two. Yeah, so that's it for this video. And I have my own channel. If you I'm popping it up on screen, probably somewhere, I don't know where. It's popping up on screen. And yes, go subscribe to that. And that's it for this video. Okay, bye.